makes use of Euler rotation along the yaw axis by pressing A and D. Does not move. The longer the button is held down, the more acceleration or torque is applied to it. As you can see there, the button is let go and it starts to move on itself. Spacebar will quickly detorque or decelerate, activating the brakes in space. Then rotates along the pitch axis. Again, the longer the button is held down, the more force is applied to it. So this is a slow rotation, as only a select amount of force was applied to it. Making use of vector rotation in order to do this. As you seen in this next little clip, the more force is applied, the quicker it moves. So it starts from 0 and then it slowly accelerates the longer the button's held, the more thrust is applied, and then it's a quicker rotation. Next you will see vertical movement, just up and down. If you look at the planet for a reference, it will move up vertically using vector maths, and then move directly down without the spaceship rotating. Again, physics are applied to this, so the longer the button is held down, the more it will accelerate, the faster it will go, eventually releasing the button and it will move on its own. To bank right, first of all, the ship will move forward and then start to rotate right until it's at 45 degrees, and then it will move to the right while still accelerating forward. Again, same with the left one. Used Euler rotation for this feature, but once rotated, have to use normal, just simple vector movement, otherwise it would move on its local axis and not move, banking left globally. If the W forward button is pressed, then the ship starts to accelerate, and the closer it gets to the planet, the gravity's pull will pull it closer and increase its acceleration, making a slingshot maneuver. To move forward, the system calculates its Euler rotation, and then it would move forward in the direction the cylinder is facing. If you notice, there is a quaternion on the moon, which makes it rotate around the centre of the planet. Gravity works by finding the distance between the planet and the object, working out its magnitude, and then increasing the force applied to it depending on how close the object is to the planet. The ship has rotated now facing the planet after the slingshot maneuver, and here's a more visual representation of it. It gets pulled close to the planet, and it continues to accelerate whilst passing around. Here you can see the acceleration is needed to escape the pull or gravity of the planet, otherwise it gets stuck and it cannot escape the atmosphere.